This video is created for educational and informational purposes only. All narration is original and AI generated. This content does not promote violence or harm. The MQ-9 Reaper is discussed from a technology, aviation, and historical perspective. Oh, strong hook, non-boring. Imagine an aircraft that can stay in the sky longer than most pilots can stay awake. No cockpit. No pilot on board. No need for rest. Yet it sees farther, flies longer, and gathers more information than many traditional aircraft. This is not science fiction. This is the MQ-9 Reaper, one of the most advanced unmanned aircraft systems ever developed by the United States. But the real story of the MQ-9 is not about fear or force. It is about endurance, precision, and technology. Today, we explore how this drone became a symbol of modern aerial intelligence. Origin of the MQ-9 Reaper. The MQ-9 Reaper did not appear suddenly. It evolved from a growing need in modern aviation. Stay in the air longer, observe wider areas, reduce risk to human pilots. Earlier unmanned aircraft showed promise, but they had limits. They lacked power, endurance, payload capacity. The MQ-9 was designed to overcome those limits. Design philosophy. The Reaper was built around persistence. Every design decision focused on long-duration flight, stability at high altitude, efficient fuel consumption, advanced sensor integration. Its wings are long and slender, optimized for endurance rather than speed. Its airframe is clean, simple, and aerodynamic. Nothing is decorative. Everything is functional. Engine and performance, safe explanation. Unlike smaller drones, the MQ-9 uses a turboprop engine. This allows higher operating altitude, greater payload capacity, longer continuous flight time. The engine is optimized for reliability rather than raw speed. This means the MQ-9 can remain airborne for more than 24 hours in a single mission. That endurance is its greatest strength. Sensor technology and awareness. What makes the MQ-9 truly powerful is not its size, it is its sensors. The drone carries electro-optical cameras, infrared imaging systems, advanced data link equipment. These systems allow operators to observe environments in daylight, night conditions, various weather scenarios. Information is transmitted in real time. This turns the MQ-9 into an eye in the sky. Remote operation concept. The MQ-9 is flown remotely by trained crews. Operators sit thousands of miles away in controlled environments. This approach offers reduced risk to personnel, continuous mission control, precise data analysis. The drone does not get tired. It does not lose focus. Human operators rotate. The aircraft stays airborne. Global presence and adaptability. The MQ-9 is designed to operate across different regions. It performs effectively over deserts, mountains, coastal regions, open seas. Its systems adjust to temperature, altitude, and atmospheric changes. This adaptability allows it to support long-range monitoring missions worldwide. Reliability and system redundancy. Unmanned aircraft must be reliable. The MQ-9 includes redundant communication systems, backup flight controls, automated safety features. If one system experiences stress, another supports it. This design philosophy ensures mission continuity. Evolution from earlier drones. Before the MQ-9, unmanned aircraft were limited by endurance and payload. They could observe, but only briefly. They could fly, but not far enough. The MQ-9 addressed these gaps directly. Engineers focused on greater wingspan for lift efficiency, stronger airframe for heavier systems, improved propulsion for long-duration flight. This evolution transformed the drone from a support tool into a primary aerial platform. Intelligence, surveillance, and reconnaissance role. One of the most important contributions of the MQ-9 is in information gathering. Instead of reacting to events after they happen, operators can now observe environments continuously. This allows pattern recognition, long-term monitoring, early situational awareness. The MQ-9 does not rush, it watches patiently. And patience in aviation intelligence is powerful. Communication and data link systems. A drone is only as effective as its connection. The MQ-9 uses advanced communication links that allow real-time video transmission, long-distance control, secure data relay. Information flows from the aircraft to analysts almost instantly. This creates a bridge between the sky and the ground without delay. Oh, ground control stations. Unlike traditional aircraft, the MQ-9 is not controlled from a cockpit. Instead, trained crews operate from ground control stations. These environments are designed for focus, precision, reduced fatigue. Large displays show live sensor feeds, flight data, and system health. This setup allows teams to work together rather than relying on a single pilot. Oh, human-machine teamwork. The MQ-9 highlights a key principle of modern aviation: humans and machines working together. The drone handles flight stability, altitude control, endurance. Humans handle decision-making, analysis, mission planning. This balance reduces risk and improves efficiency. Technology supports humans rather than replacing them. Oh, long-range global operations. The MQ-9 was designed for global reach. It can operate across vast regions without the need for constant redeployment. This capability allows coverage of remote areas, monitoring of wide environments, efficient use of resources. Instead of multiple short flights, one long mission can provide continuous insight. Oh, automation and safety features. Automation plays a major role in the MQ-9's reliability. Built-in systems assist with navigation, altitude holding, emergency procedures. If communication is interrupted, the aircraft can follow pre-programmed safety actions. This reduces the risk of loss and improves mission confidence. Maintenance and operational efficiency. Despite its advanced systems, the MQ-9 is designed to be practical. Maintenance teams benefit from modular components, predictable service cycles, system health monitoring. This allows operators to plan maintenance rather than react to failures. Efficiency is part of the design, not an afterthought. Oh, impact on modern aviation strategy. The success of the MQ-9 influenced how future aircraft are designed. Endurance became more important than speed. Data became more valuable than altitude. Many modern aerial systems now follow principles first proven by the MQ-9. Its impact extends beyond its own airframe. Oh, looking toward the future. As technology continues to advance, the MQ-9 remains relevant. Upgrades improve. Sensors, communication, integration with other systems. Rather than being replaced quickly, the platform evolves. This adaptability ensures it remains useful in a rapidly changing aviation world.